All right, today we're going back to basics, back to the absolute bedrock of all Java data structures, the array. Before all the fancy frameworks and collections we have now, this was the original building block. So let's really break down how it works, right from the ground up.
It's so easy to jump straight to the high-level stuff, right? Like array lists or hash maps. But here's the thing. They all owe their existence to the humble array. Understanding arrays isn't just about learning some old syntax. It's about understanding how Java fundamentally organizes data and memory. It's the key to everything else.
So first up, we're going to explore what an array really is and how Java actually stores it in memory. Then we'll get into their raw power. And finally, we'll see the limitations that literally paved the way for the entire collections framework.
Okay, so this is the textbook definition, and trust me, every single word here matters. Fixed size means you can't just grow or shrink it on the fly. Indexed means we grab elements by their position number. And contiguous block of memory, well, that's the secret sauce to their incredible speed.
So these are the big rules. Fixed length, you start counting at 0, everything's got to be the same type. But that last one, O of 1, constant time access, that's the superpower. It sounds all technical, but it just means that getting the first element, the last element, or any element in the middle takes the exact same, ridiculously short amount of time. And we're about to see exactly why.
All right, now for the fun part. Let's pop the hood. To really get arrays, you have to be able to picture how they actually exist inside your computer's memory. This is the blueprint.
So, when you write a simple line of code like this one, you're not just declaring a variable. You are giving the Java virtual machine a very specific command. You're telling it, hey, go find me an empty, unbroken piece of memory that's big enough for 3 integers and reserve it for me.
And this is what it does. The JVM finds that single contiguous block and locks it down. And because we asked for an int array, Java's nice enough to initialize each slot with a default value for integers, which, as you can see, is just 0.
Okay, so now what if we want to change a value? Let's say we want to put the number 99 at index 2. Remember, that's the third slot since we always start counting from 0. The code is simple enough.
And this visual right here, this is why arrays are so incredibly fast. The computer doesn't have to scan from the beginning to find index 2. No. It does a quick bit of math and makes a direct memory jump right to the correct location. That's what a 1 access actually looks like in practice. And because all that data is sitting together in one neat block, it's also super CPU cache friendly, which is just a fancy way of saying the processor can work with the data like light.
Now, here's a really crucial distinction to make. An array of primitives, like our int array, stores the actual raw values, the numbers themselves, directly in that memory block. But an array of objects, say an array of strings, it doesn't store the strings. It stores memory addresses, basically pointers, that tell the computer where to find each of those string objects somewhere else in memory. This is exactly why an object array defaults to null, and why you so often run into that dreaded null pointer exception.
So now that we have the blueprint down, let's talk about the practical side of things, the rules you got to follow when you're actually writing code with arrays.
An array's size is set in stone. It has these really rigid boundaries. So what happens when you try to step outside of them?
Bam! The JVM will throw an array index out of bounds exception. And you know what? This isn't a bug. It's a safety feature. Our array has indices 0, 1, and 2. That's it. Trying to touch index 3 is illegal. The JVM is basically protecting you from corrupting memory by performing this check every single time you access an array.
Now, the array object itself is pretty simple. It doesn't have a bunch of methods. But Java gives us this incredibly powerful helper called the arrays utility class. This thing is packed with super optimized methods for all the common stuff you'd want to do. Sorting, searching, copying, you name it. It's your go-to toolkit for working with arrays.
So all this brings us to the big question. If arrays are so blazing fast, why did we even need to invent the whole collections framework with things like ArrayList? Well, it all boils down to a classic engineering trade-off.
This table just lays it all out perfectly. On one hand, you've got arrays. They're fixed, they're rigid, and they're built for pure, raw speed. On the other hand, you have collections. They're dynamic, they're flexible, and they're loaded with helpful tools. A huge win for collections is generics, which gives you that compile time safety so you can't accidentally put, say, a cat object into a list of dogs. And notice the collections can only hold objects, not primitives. Another massive difference.
Okay, so when should you actually reach for a plain old array?
You choose an array when the amount of data you have is fixed and you know it up front, and when performance is your absolute #1 concern. Think low-level stuff like processing the pixels in an image, reading bytes from a network stream, or building the guts of a high-performance game engine.
And when do you choose collections? Pretty much for everything else. Anytime your data needs to grow or shrink. Anytime you need powerful, ready-to-go algorithms for sorting or filtering, or anytime you value clear, safe code over squeezing out that very last nanosecond of speed. For most day-to-day coding, collections are going to be your best friend.
So let's bring this all home. Arrays are fast, simple, and super memory efficient, but man, are they rigid. And that inflexibility, that's the whole reason collections were even created. They exist to provide a dynamic, feature-rich, user-friendly layer right on top of this powerful, low-level foundation.
And this right here, this is the ultimate takeaway. Once you truly get how an array works in memory, that contiguous layout, the direct access, its fixed size, then the design choices behind ArrayList, well, they stop being mysterious. They suddenly become obvious solutions to the problems arrays have. Understanding the bedrock is the absolute key to mastering the blueprint.